Hi, welcome. Now we are going to solve the second sum in the exercise number 1.1 first division. Okay. The question here is using appropriate properties, find then a particular expression which is 2 by 5 into minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. Okay, so this bracket you must not confuse with this bracket. It just they introduce this bracket only for this number is negative. Okay, minus 3 by 7, that's all. Okay, so when you see this kind of sums right in the expression, it is better to introduce brackets for each term. Okay, what is a term? A term is separated by minus or plus. Okay, so when you see here you have 2 by 5 then into minus 3 by 7, that means this into, you must always remember that in a expression multiplication and division you must do it first. So wherever into you first introduce a bracket, then you will know, you can visualize how many terms are there in the expression. Okay, here it is into, right? So 2 by 5 minus 3 by 7 is one term. Okay, 2 by 5 into minus 3 by 7. Okay, now you have minus here, right? So what my trick here is that just tag this minus to the next term, just introduce a plus. That means it is plus minus 1 by 6. Okay, so minus 1 by 6 into 3 by 2. Okay, this 3 by 2 is into, so I can very well introduce a bracket here. So this is the second term. Okay, what is the third term? 1 by 14 into 2 by 5. So this is the third term. Why it is why we are introducing a bracket here? Because it's a multiplication. If it is not a multiplication, if it is a plus or minus, then 1 by 14 will stand alone as a term, then plus 2 by 5 will stand alone like a term. Okay, so now you can visualize and see very well that you have three terms. Okay, so you introduce the bracket already. Okay, now our next step is, you cannot simply, okay, I have 6 and 3 here, so I just cross out 3 one times, say in 6 3 two times, like that. You should not do that, because this sum is using appropriate properties. So what are the properties you have? You have commutative property, that is something like a plus b equal to b plus a for addition. Okay, similarly for multiplication, it is a into b is equal to b into a, that is commutative property. Then what you have? You have associative property. That means you have three terms like these, you can do any two terms to, you can combine any two terms together and do it first, then finally you can go for the third term. Okay, so that is associative property. Finally you have multiplication over addition, which is a distributive property. In distributive property you can very well take out the common factor or the common multiplier out. Okay, that is distributive property. So what you can see here is the in any two terms or three terms, is the any same common factor is there. You have 2 by 5 here. Do you have a 2 by 5 here? But here it is 2 by 5. So this first term and the third term put together, you can take 2 by 5 as common using a distributive property. That is the idea. Okay, so what I need to do is, I need to bring the third term to second and the second term to third. Okay, so this way I can combine first term and the last term together. Okay, so for that, how can I bring the third term to second term and push the second term to third? Only by commutative property, because commutative property says that a plus b equal to b plus a. Okay, so by commutative property, what I am doing here is that I just bring the third term to the second term. Okay, I just push the second term to the third place. Okay, I am interchanging the terms. Okay, that is possible only by commutative property of addition. Okay, Okay, now what I am doing here is that again, if you see this two terms, 2 by 5 is common, but here it is 2 by 5 into minus 3 by 7, here it is 1 by 14 into 2 by 5, so the order is different. Okay, but this order also I want to make it in the same order to make sure it is I will use the distributive property. Okay, so how can I change the order? Here is 2 by 5 minus 3 by 7, I am not touching anything here, but here 1 by 14 into 2 by 5, is it possible? Can I put it as, write it as 2 by 5 into 114? Yes, it is very well possible, because a into b is nothing but b into a. Okay, you can anytime write a into b as b into a, because the commutative property of multiplication is like that. You can just change the order, it won't affect the multiplication. Okay, so for the first term I just keep as it is, second term 2 by 5 into 14. Okay, instead of 1 by 14 into 2 by 5, I written this one as 2 by 5 into 1 by 14. Okay, this is two terms. Then the final term here is the minus 1 by 6 into 3 by 2, which is the same thing I'm keeping. Why I'm not cancelling this 3 one time, 3 two times here? I can simplify this, but my idea is not to simplify. I just expect 1 by 6 or 3 by 2 coming out of this result. Okay, so I'm not doing anything on the third term. By I just put by multiplicative property of multiplication, commutative property of multiplication. Why it is multiplication? Because I changed the multiplication order here. Okay, so now it is very visible and it is very obvious that 2 by 5 into is distributed in both the terms. So I can take out 2 by 5 into outside. Before that I must say I'm going to perform a addition operation within first two terms, not all the terms together. How can I say this? Associate only two terms, that is by associative property of addition. So associative property of addition, I just introduce another bracket telling that I am going to do addition with these two terms. Okay, I am not touching the third term. Okay, now 2 by 5 into minus 3 by 7, 2 by 5 into 1 by 14. So 2 by 5 into I am taking out. So when you take common, you must always remember that it is always with the operator. You cannot simply take 2 by 5. You must also it is 2 by 5 into. So because the property itself is telling that distributive property of multiplication over addition, it is because of multiplication is distributed, only multiplication is distributed, that's why we can take out the multiplication outside. So 2 by 5 into, so this is the multiplication over addition, both the terms by addition, right? So you are taking out 2 by 5 into out. So when you take out 2 by 5 into out, what is there in the first term? Only minus 3 by 7, that is the remaining thing. Because you cannot say, you should not say into also remaining. No, you have already taken 2 by 5 with into. Okay, so minus 3 by 7. Similarly, this 2 by 5 into is already taken out, so you got 1 by 14. If you distribute NC, 2 by 5 into minus 3 by 7, this is in the first term, plus is here, 2 by 5 into 1 by 14. Okay, that is what coming here. So this is done by the distributive property of multiplication over addition. This is multiplication over addition. Okay, then the third term I'm not doing anything. Okay, now you see 2 by 5 minus 3 by 7 plus 1 by 14. Now you see the denominators are different. If the denominators are same, then I can make it as a common denominator and add the numerators. But if the denominators are not same, then I must make it as a same denominator. How can I do this one? because I'm doing within this bracket. Now I'm doing a addition within this bracket. So how can I do this? So I take the LCM 14 and 7. What is the LCM? 7 is the prime number. 7 in 14 2 times. 7 in 7 is 1 time. Then 2 comma 1. Now 2 in 2 is 1 time. Just put the 1. So you have the LCM of 14, which is 7 into 2, which is 14. So the second term here within this bracket 1 by 14 won't be changed because the LCM itself is 14. Only thing is I need to change this guy, the first term 7 to 14. How can I change it? I can multiply with the 2 very well, because the LCM itself is giving you a clue that 7 into 2 is 14. So I multiply the denominator with the 2. If I multiply anything in a fraction, the denominator with any number, I must use the same number, same multiplication on the numerator. Then only it will be an equivalent fraction and the value won't be changed. If you are not multiplying with the same number, then the answer will be wrong. So the fraction value will change. So whatever I do in the denominator, I must do the same thing in the numerator. That is what I am doing here. Okay, so I multiplied 7 with 2, which is the denominator, minus 3 into 2, which is numerator. Okay, so automatically the third term is same. Automatically it becomes 14 down. Okay, so it is 7 into 2, 14. This denominator is also 14, so I can very well make it as a common here. So minus 3 into 2 is 6 plus 1. Okay, minus 6 plus 1. Okay, the third term is remains like this. Okay, then you have 2 by 5 into minus 6 plus 1 is nothing but minus 5 by 14. Okay, so plus minus, this is the third term. Now I simply simplify this one. Minus 5 minus 5 minus 1 times 5. Here in 5 it is only one time. 2 it is only one time. 14, if I divide 14 by 2, 7 times. 2 remains 7 times here. So when I simplify this, just 5 cancel, 2 1 time, 14 7 times. Okay, minus 1 by 7. But if you see here, I get only minus 1 by 7, which is not in the third term. So I just simplify the third term, because I was expecting that the third term 3 by 2 or 1 by 6, I will get it here in the first term, so that I can again introduce the distributive law of multiplication and take a common. But it is not happening, so I just simplify here. Minus 1 by 6, 2 times, in 3 only one time. Okay, 3 in 6 it is 2 times. So finally what I have is minus 1 by 7 plus minus 1 by 4, which is equal to, again it is 7 and 4. Similarly last time, I need to do it common denominator. So for that I need to take a LCM 7 comma 4. So I am finding a LCM which is in 7 it is only one time. 4 I just bring it down. So I put 4. It's supposed to be 2, because you always make the LCM using 2 and 2. Okay, prime numbers. I just put is 4, but it's supposed to be 2. Okay, so 2, then it will become 2. Then again one more time 2, which is 7 into 2 into 2, which is 28. Okay, so the LCM is 28. So how can I make the first number to get the denominator 28? By multiplying 4, because the LCM itself is giving the clue. So 7 into 4, which is 28. So minus 1 into 4, which is 4. So whatever you do in the denominator, you must do it in the numerator. Similarly, this term also 4 into 7. So I am multiplying with 7. So the numerator also I must multiply with 7. Okay, so finally you get both the denominators 28. So you get minus 4 minus 7 in the numerators. Because both denominators are 28, you can make it as common. Then you can add both the numerator. So minus 4 plus minus 7, you get 28. Minus 11 by 28 is the answer. Okay, so I hope you could understand how this sums has to be done. Okay, because you can, in the first place itself, you can strike off this 6 and 3, but you should not do it, because this sum expects you to apply this commutative law, distributive law, and the associative law. Okay, so I'll just recap whatever I have said now. Whatever the terms, your idea is you just tag that minus to the next term. Okay, that is one. Introduce the brackets so that you can visualize properly what are the terms there. Okay, here it is 3 terms. Okay, then you identify is there any common there. Okay, common in any of 2 terms. Any factor is common in common factor in any of 2 terms. Obviously here 2 by 5 is here 2 by 5, so I must bring those 2 terms together. How can I do that one? Using the commutative property of addition. Then similarly the order of multiplication also you can change it using commutative property. Okay, then you go down, you can associate any 2 terms using a bracket and do the addition. Okay, then take out the common with the common factor with the multiplication using distributive property of multiplication. Finally, whatever simplification you want to do, you can do it within the fraction, but remembering denominator must be same. How can you make the denominator same? Using a LCM. Okay, then simplify, you get the answer, which is minus 11 by 28. Okay, so if you have any doubts or any if you find any suggestion to improve our videos, just let us know, then put it in the comment, then we will improve it. Okay, God bless you. Thanks.